box here is the square root of 2 times D times the ordering cost over the storage cost, which I don't remember if that's S, but let's see if we can get these down. So the demand is 915 bottles.
Okay.
The cost is $9 to place an order. That's C. And storage cost is $4. And typically this works out like perfectly.
Okay, and the D, okay, D's demand.
Yeah, D is demand. And that's S. 915. If you have a calculator, I'd encourage you to try the calculation with me.
Okay.
Didn't work out nicely. That doesn't seem right. These typically work out nicely. Let me double check that is.
I got 64.167.
Yeah. 2 times G, 2 times D times the cost for the order divided by that. Yeah, I remember it working out nicely the last time I did this with students. So yeah, I got 64.
Okay. Yeah, I also
So
got that.
okay. Now the part B here, you take the demand for part B, another formula here. You
What
take
does
the
S,
demand,
sorry, what does S stand for?
the cost to store the bottles.
Okay.
And that might not be the right variable letter. Like I just chose S. I don't remember what it's called. I mean, this has a standard form.
Okay.
Um,
That's
so the demand over they call this Q that we just found. So the demand over Q, so it's 915 over the number you just found. You don't want to use the rounded value though. So if you can keep that old number
it's
is the 64.1677 anyway.
7.
This one does say to round to one decimal place, so I got 14.3 for that.
Oh, and for that one you did. Wait.
So the second, the B is the demand 915 over the Q. Q is what came from part A. So this is part A, this is part B.
And it is part 8 64. But would I put
Yes, yes.
64.1677?
It says type a whole number, so I'm going to go with the rounded 64 number.
Okay.
Is that okay?
Yeah.
I don't love that, but that is the best I can say.
Okay.
Is that okay for that
Yeah.
one?
Sorry. Yeah, I got
No apology needed. You're the customer. You'd say, you know
it.
what, Matthew, that was a terrible explanation. Do it
No,
again.
no, it's fine.
I'll try to do better. All right.
Okay.
The elasticity of demand, E. E is a formula. It's minus P over Q times dQ dP. And so the P is the variable. Q is this function here, and dq dp is like q prime. So you need to be able to take a derivative of this. We talked about that last time, like how important being able to take derivatives are
Mhm.
for this course. I mean, not in life, but for this course. So the derivative of a constant is 0. The derivative of this minus 7p squared, you bring the 2 down times that's -7, and then you subtract 1 from the exponent. So it's -7 times 2 p to the 2 minus 1 power, which becomes -14 p.
Wait, where did the 35,000 go? Did that just
That
go
goes
away?
away.
Okay,
The
so
derivative of a constant, d dx
oh right.
of
Got
a
it.
constant is 0.
Okay.
So now we have all the pieces for this. It's minus p over 35,300 minus 7p squared times -14p. Okay, so we should simplify just a tiny bit here. If we multiply the minus p times the minus 14, you get 14p squared, 35,300 minus 7p squared, like that. That's the answer to box number 1.
Okay.
Take a look at that and just see if you're okay with where everything came from.
I think so.
Okay.
Yeah.
So there's a couple of ways to do this part B. The first way is that revenue is maximized when elasticity equals 1. So when you set this equation here equal to 1. The other way to do it is to go back to the original equation, Q, and do write the revenue equation. Revenue is price times quantity.
Okay.
That's probably the way I would suggest us do it. So it's price times 35,300 minus 7p squared. Well, I take that back. No, we should do it. We should do it the other way. This is gonna be harder to do it this way.
Okay.
Well, I'm sorry. I know I'm going back and forth here. I'm trying to figure out what's best for you. This one you would have to graph and figure out where it's a peak. This one you
Is
could
that my
graph or
calculator?
kind of solve. Do either of
Okay.
these ways stand out to you?
Um,
It's like what you would do on an actual test.
I think the graphing might,
Okay.
I
Do you
think.
have it? Do you have your calculator available?
Yeah.
It's okay
Yeah,
if
I
you
have it
don't.
on here.
Okay. I mean, you could try graphing this. I mean, for these lessons, I generally just graph them in Desmos, which again, I know doesn't really help you because you can't use that on the test. But
No, that's
if you would
fine.
like, I can show you how to do it on the calculator now.
Okay. Wait,
What
I
would
have
you
a
like?
question.
Yes.
I think I missed where the one came from.
Well, there's two ways to do this, part B. You can
Oh,
either
okay.
set
Sorry, I
the
thought that
price
meant.
elasticity of demand equal to 1, or you can solve the revenue equation.
Okay, never mind. I thought, okay, never mind. I think the revenue equation looks the most familiar, but I don't.
I've got a graph here. Make this smaller so it's easier to see. So like I said, the graph, if you graph this equation, you can get the max right there. That tells you the value of P. P is basically 41. There, I know it's just 40.999, but it's basically 41. And then we got to go back. Is that what it wants? No, it wants Q. So to get Q, you have to put 41 into this function right here.
Okay. And where did the three come from? The P to the third P.
When you multiply n by P, 35,300 times P, and then 7p squared times P, you add 1 to the exponent. Like it's really
Okay.
P to the 1 there.
Okay. And then you put the 35,300 P minus 7P into the calculator and it got P
Yes.
equals 41.
You graph the max is when P is 41,
Okay.
but that's what goes back into this equation up here for Q because it's asking for Q. Q is 35,300, 35,300 minus 7 times P squared.
Okay. And we put the P into the original or the derivative?
The original.
Okay.
And these are all good questions. These are all the standard questions most students have in this course. Like where does it go back into and why? Is that okay?
Yeah, and Q equals 2, 3. Okay. Yeah.
These are really complicated to start. After we get through this next question, it's slightly better.
Okay.
All right. Short-term demand for crude oil in country A, here represented by this equation here. Calculate, interpret the price elastic demand when the price is $59 per barrel. All right. So again, elasticity of demand is minus P over Q times the Q P. They're giving you the price of 59. All right.
Okay.
You are going to, you have the equation for Q, and then we have to take the derivative of this. All right, so let's start by taking a derivative of this, call it Q prime, that's dQ dP. It looks worse than it is. You're just bringing the exponent down. So it's the 1846.114p minus 1.16 times minus 0.06. So that's the derivative is you bring the exponent down and then you subtract 1 from the exponent.
1. Oh. Okay. Wait, why is it? Oh, is it supposed to be decimal? The 1846?
No, sorry.
Okay, sorry.
Uh, good catch. I do make mistakes, so please always ask. All right, so the E here, the formula for E is minus P over 1846114 P to the minus 0.06 times 1846114 P to the minus 1.16 times minus 0.06. And you might be wondering why I'm writing all this out. It's because there's going to be some cancellations.
Okay.
Okay, so this number cancels with this number. Okay.
Okay.
And then when you have a negative, when you have the bases are the same, there's a lot of things going on here. So when the bases are the same, you add the exponents. So because P and P are the same, you can add the exponents. So it's 1 plus minus 1.16. But then you subtract the bottom exponents, you subtract negative 0.06. Sorry, I have the wrong exponent here. I'm so sorry. I'm being very sloppy today. It's 0.606.
Okay.
I just not adding well. All right. So this becomes 0 because the double negative becomes plus 1 plus 0.06 is 1.06 minus 1.06 becomes 0. So this becomes 0. And then the only thing that's left over is the negative in front of this, and this negative becomes 0.06.
That's all
So
that's left.
that's your answer to box 1.
Okay. And that's the E.
That's the E.
Okay.
And then for whatever reason, it's the same answer for box two. So this is one of those problems where like if you get it on the real test, you would know that it's just the exponent without the negative sign at the answer.
Okay.
Because they tend to reuse the question. So this is the same for the first two boxes.
Okay.
And then there's this definition that I have to look up about whether it's inelastic or elastic. And it has to do with whether it's um, relative to one. So let me look this up.
Okay.
I never remember it. Okay, here is the short of it. See if I can grab a. All right, this looks like it was written a million years ago, but this is it. So if it's greater than one, it's called elastic. If it's less than one, it's inelastic.
Okay.
Um, and this is confusing over here. Basically, if it's inelastic, you want price to go up. And if it's elastic, you want price to go down. So in your problem, it's inelastic. Um, price should increase and revenue will increase.
So the last one?
Yes.
Okay.
Okay. On to something maybe slightly more clear. We'll see. Okay. Find dy dx using implicit differentiation. So implicit derivatives are a lot like regular derivatives with just a tiny little wrinkle. For 7x cubed, the derivative of 7x cubed is the same as always. So you bring that 3 down and you subtract 1 from the exponent.
Okay.
So that becomes 21x squared. And what I'm hoping for over time here is that you'll eventually just be able to go from 7x cubed to 21x squared.
I hope so.
We'll be optimistic here. So with y, it's one big difference. So you take the derivative just like you did for x. So you bring that 2 down, you subtract 1 from the exponent. But whenever you take a derivative with respect to y, you write a dy dx.
You write it in the equation?
Yes.
Okay.
So you may not know why or fully understand, but this is what you do. All right. Plus, now the derivative of 7y is just 7, but again, it's dy dx. Whenever you have a y, whenever you take a derivative with respect to y,
Okay.
there's a dy dx.
But not when you take a x.
Yes, that's correct.
Okay.
Which is, weird, different, or why. That's, but
Okay.
we can do this. So now that calculus is over, believe it or not, calculus is over. So it's just an algebra problem from here. You generally move the dy dx's to one side. They're already on one side, so you don't have to do that. Um, but then you have to factor it out. So you're going to factor out a dy dx from both on the right side. I'm just factoring it out. And then you divide both sides by what's left inside parentheses. Those cancel. So your dy dx is 21x squared over 4y plus 7. That's your answer.
Okay. Oh, okay. Okay.
Any questions on that?
No, thank you.
Okay. All right. Like, and normally you would do a bunch of those. You know, I think I made this comment to Anna that it seems like in some ways this class is harder than what I see at Eller.
I
Just depends on
know.
who's teaching it, time of year, stuff like that.
Yeah.
Okay.
I feel
Uh,
old.
yeah, next problem here. So we got to find the derivative again. For tangent lines require two things. They require you to take a derivative, and they require a point. You have the point already. So the derivative here, just the same way as the previous problem, when it's with respect to x, just the same old standard, derivative with respect to x. So that's 2x. The derivative of y squared is just like with x. It's 2y, but you add in a dy dx.
Okay.
The derivative of 41 is a constant. That's 0.
Okay.
And your goal now is to solve for dy dx. So like I mentioned, there will be a problem, probably the next one. Yeah, the next one, where you have to move the dy dx's around. But for this one, you just have to, it's already on one side. So you just move the stuff that's not a dy dx to the other side. And then you divide both sides by 2y. dy dx equals negative x over y. All right, and then you put in the x and the y, and you're like, what x and y? Well, they gave you an ordered pair here. They gave you -4,
Oh,
comma -5. That is your x and y. So it's minus a -4 over -5, which is 4 over -5, or -4/5. Right. Any
okay.
questions on that?
No.
Okay. So now in terms of like what to write in here, the best equation of the line to use is y minus y1 equals mx minus x1. This is called point slope form.
Oh, right.
And you have a point. Your point is -4, comma -5. And your slope is the derivative -4/5. So you do simplify signs. Like you don't just leave it like that. We did it that way. -4/5 x minus a -4. So this becomes y plus 5 equals -4/5 x plus 4, like that. Now, if you notice the way the answer is written, it's y equals and then a box like that. I think
Okay.
it'll accept if you subtract the 5 from the other side. If you just write -4/5 x plus 4 minus 5, I think it'll accept this in the box there.
Okay. This would be okay.
Like you don't have to distribute the -4/5 and then combine like terms. I think it'll take that as is.
Okay. All right.
Yeah, questions on that?
No. Thank you.
All right. So next problem here, this is the more difficult one. Like this probably would not appear on your test, like the previous ones could, but probably not this one. So the first thing here is like before you even take a derivative, uh, there's um there's no there's no y value. Okay, and to get y, you have to put this x value in. So the way this works is it's y cubed plus 3y squared minus 61 equals 3 plus 3y squared, like that.
Okay, so the first step you would plug in 3.
Yeah, or whatever the x value is.
Okay.
Now these cancel. You can just subtract those out, and if you add 64 to both sides, you get y cubed. I'm sorry, 61 to both sides. You get y cubed equals 64, so y equals 4. Usually y is a nice value, like it shouldn't be anything really weird.
Okay.
Is that okay?
Yeah. Okay.
All right, so now we've got the order pair 3 comma 4. So now we have to take a derivative of this. So the derivative, just like the previous ones, when you have a derivative with respect to y, you treat it like an x. So that's 3y squared, but then you add in a dy dx. Okay. The derivative of xy squared is product rule. Do you remember that at all from previous part of the course?
No.
Okay. So we'll cover it really quickly here, but it's going to come up again. The product rule says to keep the first, which is x. There are two functions here, product of two functions. It's an x and then a y squared. Keep the first, take the derivative of the second, which is 2y dy dx, plus take the derivative of the first, derivative of x is 1, keep the second. Okay, and if that didn't make any sense, that's okay. We'll deal with it later. Derivative of minus 61 is 0, equals, now the derivative of x is just 1. The derivative of 3y squared is 6y dy dx.
Okay.
All right, so from here, you have to move everything to one side, all the dy dx's to one side of the equation. So we're going to move this one, the minus 60y dx, to the other side. And then we're going to move the minus y squared to the other side of the equation. It's potentially a lot of writing.
Yeah.
And, that's, I don't know what to say. All right, equals 1 minus y squared. But the pattern is basically the same. Like you move all the dy dx terms to one side, the non-dy dx terms to the other side. Then you factor out a dy dx. But none of these steps individually, like none of this is impossible or beyond your abilities. It's just maybe putting it all together that is the challenge.
Yeah.
And then you divide both sides by this. And I wish you were done here. I wish this was all it was asking for, but this is only a piece of it. You have
Lot
to
of
then put in
writing.
your x and y. Sorry, what were you gonna say?
Nothing. I just said it's a lot of writing.
Yeah, yeah.
Okay.
So now you got to put in your x and your y and get the equation. So uh, this is 1 minus 4 squared, which is 16. 3 times 4 squared plus 2 times 3 times 4 minus 6 times 4. So negative 15 over, what is that, 48 plus 24 minus 24. And then these divide by 3, so negative 5 over 16. That's your slope. That's just all calculator work. There's nothing special about that. So if we, it's kind of like we're so deep, down in the weeds, as they say, like, what are we even trying to get? We're trying to get the equation of the tangent line. The equation of the tangent line is y minus y1 equals m x minus x1. Your point is 3 comma 4, and your m is minus 5 over 16. So you actually have everything now. It's y minus 4 equals minus 5 over 16 x minus 3. And then you can add 4 to both sides. And this is what goes in the box there. And you take a deep breath.
Could you scroll up for just a second?
Sure, sure.
Okay.
Again, yeah, but I'll always send this to you at the end, but glad you're getting it down now.
Okay. And then you go back down.
All right.
Okay. All right.
All right. Can we move on to the next one?
Yes.
All right. Okay. For this one here, we're going to take a derivative just like we've been doing. But now we're finding the second derivative, so there's more work to do. The derivative is 10x plus 14y. So I'm just bringing that exponent down in both cases. With y, you add in a dy dx equals 0. I'm actually going to copy this over here to the right.
Okay.
And we're going to do, on the right here, we're going to solve for dy dx. But on the left, we're going to keep going with the derivative.
Okay. What does it mean when it's d, like the dy dx has the 2?
That means the second derivative.
Oh, okay.
So the derivative of the derivative.
Okay.
It does have physical meaning. It just, you know, it's that, but in terms of this problem, you just got to keep going. So
Okay.
on the left here, the derivative of 10x is just 10. Okay. The root of 10x is just 10. In the middle here, this is product rule. Like, and I kind of was alluding to that before. Like it's the products are 14y and dy dx. So we're going to keep the first. This is the product rule. And then you take the derivative of the second. That's where you get the d squared y over dx squared. Plus the derivative of the first is 14. Derivative of 14y is 14, but there's a dy dx. And then you keep the second. Okay. So even if you didn't fully understand that, like it is there, be in the video, look back later on.
Okay.
All right. So just a tiny bit of simplifying here. This is on the right here, dy dx squared. When there's two of them, which is different than the d squared y dx squared. The one over on the right means that it's the derivative squared. This means second derivative. So now
Okay.
we're going to solve for d squared y over dx squared. So you're going to move the 10 over, the 14 dy dx squared over, and then divide by 14y. I'll show that here in steps here. And you divide both sides by 14y. The d squared y over dx squared equals minus 10 minus 14 dy over dx squared over 14y. And you might think, well, we're done, but we're not. We need to figure out what this dy dx is. So that comes from all of this up here. So I know I'm sorry for all the scrolling, but we do need to solve this for dy dx.
Okay.
So you have to subtract 10x from both sides. Divide by 14y. So we have dy dx equals minus 10x over 14y. That is what's going into this parentheses here. Did I say 14y? Yeah, 14y squared all over 14y. And what I don't know is if it will accept this unsimplified form. It's not terrible to simplify this, but do
Okay.
you want us to keep, you want me to keep going here on this one?
I don't know.
I think we should. I think we should.
Okay.
I just to be safe here. So
Okay.
when you square, you get 100 x squared, and then it's 14 squared y squared, like that.
Okay.
And then this is going to be a little bit odd, but I'm going to write this as 1 over 14y, like that, off to the
Okay.
side.
Why doesn't the 14 like turn into a number like 10 did?
It does. I'm going to cancel, and
Oh, okay.
I want you to see that, guess.
Okay.
So now when you multiply in, you get minus 10 over 14y minus 100 x squared over 196y cubed.
Okay.
And then if you, such a nightmare, minus 5, we divide everything by 2, 50 x squared over 98y cubed. And I guess we can do it again here, 25 x squared over 49y cubed. That will probably be your best simplified answer.
Okay. Okay. Is that yeah?
All right. We're definitely not gonna get everything done. I thought we could get through more, but it doesn't look like it. So I'll try to go through as many questions as possible. The time we have left.
Um, sorry, I'm just finishing writing this.
Sorry, no, I'm sorry for rushing.
No, it's okay. Okay.
All right, so I want to move on to this manufacturing problem. It looks more difficult than it actually is. So they give you some sort of a cost equation, and they tell you that production is changing at a rate of 14 units. That's dx dt is 14, and they're telling you that x is 70.
Okay.
Okay, so we need to take a derivative of this, what's called dc dt, which is
Okay.
really just another derivative. So the derivative of this is you just bring the exponent down. So it's 0.2 times 2x to the 2 minus 1. But then in these problems, these are called related rate problems. You add in a dx dt for related rate problems. So this ends up being 0.4 times x dx dt. And you have x is 70, dx dt is 14. So it's 0.4 times 70 times 14.
Mhm.
Which is 392. And I think this is like increasing or decreasing or going up or going down.
Yeah, it's decreasing or increasing.
Okay.
All right.
All right, so we're gonna go to the last question. That's probably the fastest one we can get done. Believe it or not. It says the rock is thrown into a still pond, moving outward from the point of impact, forming the circle. So the area of a circle is pi r squared, and I'm telling you that the area, the radius is dr dt is 2 feet per second, and they tell you that the radius is 10. So we're taking a derivative of this thing right here, this function. And the question always arises like, do I have to remember my formulas for area of a
Yeah.
circle? The answer is yes. So dA dt, pi is a constant. The derivative of r squared is 2r, 2 minus 1 times dr dt. So this is 2 pi r times dr dt. All right. So you have all these values, 2 pi, your radius is 10, your drdt is 2, which ends up being 40 pi. But this is rounded nearest thousandth, so you got to go to your calculator there. 125.66664. That's what I got for that one.
Okay, so I wouldn't include pi in the answer. I'd include like I would did.
You go to the calculator.
Okay.
Yeah, like that. Okay, so let me really quickly make a comment about this problem here. It is probably almost exactly the same as the one that I did for Anna. Also, a lot of these are in Chegg if you
Okay.
find it's hard to look these up. But we are basically out of time for today, so we'll have to stop here. I know we didn't get through everything. You probably
That's
need
fine.
another half hour to get through everything, but I'm gonna go ahead and stop right here. Why did I do that?
Okay.
Stop the recording. All right.